For years, we've all watched those videos of humanoid robots acting basically like flashy internet tech demos. We've seen the clips of machines awkwardly shuffling across the stage or maybe doing a backflip, right? And the comments are always joking that the robot apocalypse is still like 100 years away. Well, something massive fundamentally shifted this year. 2026 is the year these robots finally evolved from those viral stunts into entities that are literally actively disrupting our reality, our economy, and even our psychology. So let's get into it. In today's explainer, we're going to hit 5 key areas: crossing the uncanny valley, the factory floor showdown, redefining the robot body, the wild frontiers, and finally, the societal impact. To truly grasp the magnitude of this shift, we just have to look at how unbelievably fast this technology has accelerated. Just a decade ago, back in 2016, we had the activation of Sophia. Remember her? A robot with a human-like face that could mimic basic expressions and hold a simple chatbot-style conversation. Fast forward to 2024, and the leap is just staggering. BMW signs a commercial agreement with Figure for real industrial labor. And now in 2026, we're seeing the deployment of highly advanced embodied systems, like mecha and Moya, that are completely blurring the lines of what it means to interact with a machine. Let's start with part 1, crossing the uncanny valley and the psychological shock. We aren't just dealing with machines that look like us anymore. We're dealing with machines that are successfully hacking our deepest psychological barriers. And there's a really eerie fascination to this. Think about this for a second. 32 to 36 degrees Celsius. That is the exact surface body temperature of Moya, which is a Chinese humanoid robot designed by DroidUp. They intentionally designed it so that when you stand near it, you don't feel cold metal, you don't feel plastic, you feel warmth. Human warmth. Humans instinctively associate warmth with life, meaning this specific design choice completely bypasses your brain's mechanical defenses. You suddenly stop interacting with a tool, and your brain actually starts treating it like another person standing in the room. And that perfectly captures the concept of embodied AI. It's not just a machine pretending to be human, it's a system triggering your actual biological instincts. Take the robot a mecha, for example. A mecha uses 61 degrees of freedom and spatial audio microphones. This lets it maintain natural eye contact, reproduce tiny micro-expressions, and, get this, actually build ongoing social memories with users. Meaning, yes, it will remember if you were rude to it yesterday. We are officially crossing the uncanny valley here, guys, because these machines don't just imitate movement anymore. They imitate presence. Moving on to part 2, the factory floor showdown, economic reality versus hype. So if these machines can mimic our emotions and presence, the next logical question is, are they actually doing our physical jobs yet? Well, when we contrast the two major competitors side by side, a pretty fascinating picture emerges. On one side, you have Figure 3. They have an active deployment over at BMW, where their previous model contributed directly to the production of over 30,000 X3 vehicles during a 10-month stint. On the other side, we have Tesla's Optimus. Now, despite massive hype, Optimus is currently limited to internal testing, and its public demos have been plagued by ongoing teleoperation controversies. Experts keep flagging movements that look suspiciously like human remote operators. So right now, the true winner is being defined by actual factory floor deployment, not viral videos. The current state of the market illustrates this perfectly. Figure holds a massive 47-point lead over Tesla when it comes to real-world traction. Why? Because Figure actually has a named paying customer actively using their robots to do productive work. On pure robot performance specs, the gap does narrow a bit, but the decisive issue today is deployment proof. It's about what you can do in the real world, not just engineering capability on paper. And if you want a powerful reality check, look no further than Elon Musk himself. During the Q4 2025 earnings call regarding the Optimus robot, he said it's not in usage in our factories in a material way. That cuts right through the hype of dancing robot videos and shows us exactly where Tesla stands right now in terms of real economic integration. Now, the absolutely crucial point is how these leading robots are actually learning. Autonomy is compounding at an incredible rate. Take Figure's Helix 2 AI. They completely replaced over 100,000 lines of rigid, hand-engineered balance code with a 10 million parameter neural network. Think about that. They aren't just programming robots to do specific tasks anymore. They're feeding them raw data, allowing the AI to dynamically master entirely new, complex tasks on its own. It's a total game changer. Which brings us to part 3, redefining the robot body through artificial evolution. While some engineers are out there perfecting the humanoid form for the factory line, others are completely pushing the boundaries of what a robot body actually is. We are shifting into the wild, almost unbelievable world of biological engineering. Check out these terrifyingly sci-fi capabilities of a Chinese robot called GrowHR. Researchers stopped copying rigid industrial machines and started copying soft, adaptable human bone structures. This robot can expand its height by nearly 300%. It can shrink itself down, crawl, swim, float, and because it's so lightweight, it can even fly short distances. Just imagine a rescue tool that can squeeze under a collapsed wall and then literally inflate to lift the debris off of you. This evolution is happening in distinct steps. First off, engineers are using programmable materials powered by heat instead of traditional motors. But it gets wilder. Scientists have actually developed neurobots. These are living, biological robots made from frog cells integrated with actual functioning neurons. And they've even observed unexpected genetic behavior beginning to emerge inside these constructs. The line between mechanical machine, biology, and artificial life, it's completely blurring right before our eyes. All right, part 4, the wild frontiers and deployment at the extremes. As this tech scales out of the lab, it's hitting the military domain in some highly dramatic and quite urgent ways. Through state media, the Chinese military recently revealed autonomous robotic wolf packs. We're talking about AI-powered robot dogs, drone swarms, and unmanned combat platforms all operating together. They've got dedicated reconnaissance units, logistics transport, and armed strike units. But the most notable part? The distributed AI coordination. These drones and robotic units can communicate without relying on centralized radio signals. That allows them to function collectively, essentially like a single robotic organism, even during electronic signal jamming. Meanwhile, on the civilian side, manufacturing giants are aggressively scaling up. The Chinese company Unitree isn't acting like some experimental lab anymore. They're shipping thousands of humanoid robots every single year. They've even revealed a massive 500-kilogram real-life piloted mecha robot that a human can actually sit inside and control. It seriously seems like someone in their R&D department has been watching a lot of Gundam anime. But it proves that robotics is moving super fast from pure industrial application into consumer-oriented cultural devices. Finally, part 5, the societal impact. What happens next? With robots becoming warm to the touch, actively working in our factories, reshaping their own bodies, and operating in military swarms, we have to step back and recognize the sheer scale of the philosophical and societal disruption we're facing right now. The scientific community is racing to make human-robot interactions perfectly seamless. The Multimodal Emotion Recognition, or MER, challenge for 2026 has shifted its focus entirely to dyadic interaction, meaning two-way interaction between a human and a robot. But here's the crazy part. They aren't just looking at facial expressions anymore. They're utilizing physiological signals like EEG brainwaves to train AI to deeply understand and synchronize with our exact emotional and neural electrical states in real time. In other words, a machine might very soon know that you're stressed out before you even realize it yourself. And this incredible technological leap presents a massive dual-edged sword. The potential workforce disruption is just vast. It's going to hit factories, logistics centers, retail spaces, and even service and care industries. We're looking at the promise of unparalleled economic productivity on one hand and unprecedented sweeping workforce disruption on the other. Machines are now becoming capable of replacing both physical labor and cognitive tasks simultaneously. So I want to leave you with this stark reality. The question is no longer whether humanoid robots are coming. They're already here. They're actively deployed. The question we must now ask ourselves is this: what happens when humanity creates something that no longer feels artificial? Keep your eyes on the horizon. Thanks for joining me on this explainer.